Hey, 8th graders, since I can't be there today because I am at home taking care of this sick little girl, it's deceiving. She looks cute still, but she's pretty gross right now. Lots of snot, coughing all over the place, snot directly in my face a couple times. We are going to today take some notes via a video here with an app that I'm using called TouchCast. This is an app that I might have downloaded on your guys' iPads, and later in the year, it's actually got green screen capabilities and things. I may have you do like a weather report using this app, so this might be something we use later on. But we're going to take notes on Chapter 14, Section 4, the last section of Chapter 14. On Wednesday, I want to point out we're probably going to be taking a test on Chapter 13, 14, Chapters 13 and 14. 13.1 was the only section of Chapter 13, and 14, it's sections 1, 2, and 4. So that'll be Wednesday. The test, I believe, is very short. If I looked at it, and I think it's somewhere between 14 and 17 questions, something like that. So we're going to be taking that test Wednesday. When I come back tomorrow, we'll do a very good, thorough review so that you're ready to take that test on Wednesday. When we look at your objectives for this section, the one that I'm really going to focus on when we take the test on Wednesday is the first one there. Explain tides and their relationship with the earth, the sun, and the moon. So this one here is kind of the main focus. The last one, analyze the relationship between the tides and coastal land. We're not going to get into the coastline and the effects of the erosion with the tides, things like that, because it's not tested on as heavily on the MCA. So we're going to focus on the first one a little bit. With the second one, you do have to know the names of those tides. So in focusing on that very first objective, explaining how tides are related to the earth, the sun, and the moon. They have something to do with those three things. I'm going to start off by showing a clip from Despicable Me, where Gru, using the shrink ray, is stealing the moon. So what is it that caused that surfer to wipe out? I want you to be thinking about that, and when Gru shrunk the moon, what caused the wave to drop and that surfer to crash, as we go through the notes here and talk about the reason for the tides. A common misconception that landlocked people like us Minnesotans sometimes have is that the waves coming in and out, that's the tides. Waves are not tides. When we talk about the tides are something else. Now, the waves themselves are not the tides. This is a video that's showing you what the tides are. You can see people walking along what is now the shoreline, and as you see the ocean water up there, it's getting higher and higher onto the land. That's the tides that you see. And the tides have something to do with the moon. As you saw, the surfer crashed and burned after the moon was gone because the level of the water dropped. So the rising and falling of the water has something to do with the moon. Now, what effect does the moon have on planet Earth that causes that to happen? That's what we're going to get into next here when we talk about the lure of the moon, or the pull that the moon has on planet Earth. The daily changes in the level of the ocean water, when the water rises up, like you saw in that video, and when the water goes back out to its lowest point or its lowest level, those are called the tides. The tides are influenced by the sun, the moon, and they occur in a variety of cycles. How often tides occur and the difference in their levels depends on the position of the moon as it revolves around the earth. So the blanks you should have filled in on this first slide are tides, moon, and moon, which are now all underlined for you. So first, I kind of have a question on this next slide. How long does it take the moon to go around us? This might have been something we mentioned earlier this year. If not, just take some time, make a guess, and write it down in your notes, right by the section where it says Battle of the Bulge. Take a guess. Okay, again, make a guess, write it down somewhere right here. If you said 24 hours, the pen on here is not very good. If you said 24 hours, you are wrong. It's a very common misconception that the sun and the moon travel around us, and they travel through the sky. We see that. We see them going around us. But what's happening is the Earth is spinning on its own axis, and it spins around in 24 hours' time. So the right answer to that question is not 24 hours, it's a month. And a month isn't a fixed length of time. Some months are 31 days, some are 30, some are 28. But it's about 27 days for the moon to go around us. And that gives us the phases of the moon. We'll talk about moon phases, a full moon versus a new moon, and what causes that later. But for now, as we spin on our own axis, sometimes the moon can be directly above us. Sometimes the moon can be sort of at a right angle to us on either side, or it can be directly below on the opposite side of planet Earth. When it's directly above us or directly opposite us, we have high tide in our area. When it's at a right angle to us, we have low tides. This is a diagram from your book showing the location of high tide and low tide on the Earth when the moon is in a certain position. As you can see, the moon is directly above right now what looks like the continent of Africa, and it's also directly above, Western Europe, as we can see there. And it's sort of at a right angle to, so if we draw a line through here, it's kind of at a right angle to us here in the United States. If we zoom in on Hudson Bay, what's happening in Hudson Bay is we would see that the water is going out to its lowest level in the course of a 24-hour period. We're experiencing low tide in our area at the moment. And the reason for that is literally because the water is flowing from areas where there's low tide, and it's being pulled towards those high tide areas. The same thing is happening in the west coast of the United States, or up by Alaska even. Water from here is being pulled towards the high tide areas, which are on the opposite side of the moon as well. So as I said before, high tide happens when the moon is directly above that area of the planet, and low tide happens at a right angle, or sort of a 90-degree angle, to wherever the moon happens to be. High tide also occurs on the opposite side of the moon. Now, as far as the timing of the tides, it's not the same time every single day that we have high tide and low tide. It changes because the tides occur at different times due to the fact that the Earth rotates, and that's your underlined word there that you have to fill in, rotates more quickly than the moon revolves around the Earth. There's also seasonal variation. So depending on not just the time of day, but time of the year, the tide can be much higher than normal, and the low tide can be much lower than normal. So the sun also affects the tides. And so the combined action of where the moon is as it's going around us, where we are as we're going around the sun, all those things influence what's called the tidal range. A tidal range is the difference between the levels of ocean water at high tide and at low tide. So it's actually the moon, the Earth, and the sun that are important in influencing the tides. So here's a couple different names for the tidal variations that we see throughout the season. Spring tides are tides with the largest daily tidal range, and they occur during what's called a new moon, and the one you're maybe a little bit more familiar with, a full moon. During these times, the sun, the Earth, and the moon are aligned. So when I say aligned, I literally mean the sun, the moon, and the Earth are all in a straight line with each other. You can see that in both of these. They line up. It doesn't matter if the moon is in between the sun and the Earth, or the Earth is between the sun and the moon. As long as they're lined up and we're having a new moon or a full moon, and we'll get into moon phases later, so we won't deal with that just now. But as long as they're lined up, they're going to be pulling together. And you can see in that diagram it says spring tides. During the full moon and the new moon, the sun, the Earth, and the moon are aligned. The gravitational force, and this all has to do with gravity. Gravity is that force that's pulling on the surface of the Earth and pulling on the surface of the moon as those two are creating these tides. The gravitational force of the sun reinforces or sort of helps out the gravitational pull of the moon, and they're both tugging together. So the sun and the moon are both pulling on the surface of the Earth. In this alignment that you see here, they're working together to make high tide even higher than usual. And if high tide is even higher because it's getting its water for high tide from the sides of the earth that are sort of over here, that would be the reason for the really low tides in those places. But when they're lined up, when they're in a straight line with one another, they're working together. So as you can see here, the sun is sort of pulling up on the surface of the earth. It's lifting it up right there, creating high tide in that place. And if you remember, on the opposite side of the earth, we're also having high tide. And here's the moon pulling that direction. So they're working together to make what's called a spring tide, where we have very, very high tide, and we have really, really low tides. When we're having neap tides, which are when we have the smallest tidal range or difference between high tide and low tide, that occurs when the moon and the sun are sort of working opposite to one another, and they're pulling against each other. So it's the smallest daily tidal range. So smallest is your word you fill in there. And it occurs during the first and third quarter moons, when the moon is sort of 1/4 of the way around or 3/4 of the way around planet Earth. During these times, the sun, the earth, and the moon form a 90-degree angle. And you can see that here in this diagram or this picture. If the sun is over here, it's a 90-degree angle between the moon and the earth as well. And that's a neap tide. The sun and the moon are at right angles to each other relative to the earth. In this arrangement, the gravitational forces of the sun and moon work against each other. So here we have the moon pulling up, creating high tide in this spot. So we're having high tide over here, okay, which means we are having low tide over here. But the sun is still lifting up a little bit. The sun is picking this side up slightly. So the sun is trying to lift it up. The moon is pulling up on this side. And they're tugging against each other. Which one wins? Which one has more gravitational pull or gravitational strength? Well, the moon. The moon is the winner there. And the moon is much, much closer than the sun is. And so that's why the sun has a stronger effect on the tides than, or the moon, has a stronger effect on the tides than the sun does. So the moon wins this sort of tug of war, but high tide doesn't get to be quite as high because you have the sun pulling it down in the opposite direction. They're working against each other during neap tides. This last slide about tides and topography, we're going to have you cross this stuff out. We're not going to do anything about coastal erosion or tidal bores or anything like that. So you can skip that part. Okay, and lastly, I have a short little quiz for you. Here's a picture showing the position of the sun, which is at the top of the picture there. And then you have the moon in 4 different positions, 1, 2, 3, and 4. At which position would the moon be when we have a neap tide? Remember, neap tide occurs when there's very little difference between high and low tide. The tidal range is very, very small. So high tide is not that high, low tide is not that low. When you make your guess, put it somewhere on your notes. Okay, so I wanted you to tell me which position would the moon be when we are at neap tide, and it would be here at position 2. So I'm going to circle that. It's at position 2 because the sun, the moon, or the earth and the moon are at a right angle to each other. So they're tugging against one another. Now, second question, and again, put the answer in your notes. At which position would the moon be during a spring tide? Position 1, position 2, position 3, or position 4? So for that one, if you said position number 1, you are correct. The sun, the moon, and the earth are in alignment, and so they're pulling with each other, creating very high tides and extremely low tides. They're working together.